Hello everyone. I will be presenting our work on interactive smoothing parameter optimization in DBT reconstruction using deep learning. This work has been done at Computer Science Department in Stony Brook University. In medical imaging, the volumes are reconstructed typically using a penalized weighted least squares algorithm. The objective function in such algorithm can be formulated as shown here, which consists of two terms, L mu and R mu, where L mu is the projection consistency term and R mu is a regularization term. The regularization term can also be taken as a smoothing prior, and the strength for it is determined by the parameter beta. The impact of beta on the image quality is shown below, where it can be seen that a volume which has been reconstructed with beta equals to 0 is overly noisy, while increasing the beta beyond a certain limit results in an overly smooth image where the calcifications are lost. In this work, we want to give an interactive control to the practitioner such that they can tune this image quality as per their needs and their subjective assessment of the image quality. For this purpose, we propose a CNN based model. The CNN is trained to imitate the output of a PWLS algorithm's output for a wide range of beta. The trained CNN can then be used by the practitioner to instantly change the image quality. For this, we add certain modifications in the widely used UNet model, as shown here. The UNet model takes as input the image which has been reconstructed with beta equals to 0, and it takes another parameter beta, which is the smoothing strength which needs to be applied on this image. Beta in this case passes through a fully connected layer, and all the feature maps in both encoder and decoder are multiplied by the output of this layer. In this way, a conditioning is applied on the given image such that the output is closely aligned to pre-WLS output for that given beta. We train the model using mean absolute error loss between the model's prediction and the ground truth PWLS output. The beta is uniformly sampled in a given range. We conduct experiments on 3 different datasets using 2 priors, Huber prior and quadratic prior, as shown here. The distribution of the images in the 3 datasets is shown in table below. The 2 datasets on CT, Lodopep CT and the cone beam walnut CT are taken from these 2 papers. DBT dataset is our private dataset. Quantitatively, we measure the accuracy of the unit's output and the ground of the unit's output by using metrics such as SSIM, mean absolute error, and RPSI. We observe that as the value of beta increases, the performance of the unit's prediction decreases. We also observe that the performance on CT datasets is better compared to DBT, which is because of a larger context in case of CT datasets. For more details about the experiment, I refer you to the paper. Here is a qualitative example of unit's output and the ground truth for a DBT case. We observe that the images are perceptually indistinguishable. However, the difference between them becomes apparent when we plot the power spectrum analysis. We see that the difference grows as we increase the frequency. We also plot a line profile over calcifications, and we observe that the unit's output and the ground truth are very closely aligned. And here is a sample on a walnut CT case, and here is a case from the low dose lung CT scan taken from the Lodopep CT, and this is a zoomed view of the previous slice. Now Performing the filtering using the modified unit on a given image of size 3000 cross 1200 would take around 0.22 seconds on a 2080 Ti GPU. And taking a typical size of a DBT volume of dimension 3000 cross 1200 cross 40, it would take on an average 10 seconds, which is significantly lesser than performing reconstruction from scratch, which on an average would take 1 minute on the same GPU. So to conclude, the CNN models can imitate the output of PWLS algorithm for a wide range of beta. This allows for interactive control of the image quality depending on the task at hand and the subjective assessment by the practitioner. Future work all includes automatically determining the optimum beta value for a given lesion, which could be detected using any other algorithm. The code for this model is shared at this following link, and I also share related work. Thank you and questions.